Hello and thanks for using TickBoom. A student has sent through this question which has two parts, but they're only needing help with part 2. But part 2 leads on from part 1, and part 1 says to explain why every complex number z, where z is not 0, can be expressed as z is equal to w plus 1 on w for some complex number w by considering w squared minus zw plus 1 equals 0. So that I'm going to take as given. We'll leave that. The student doesn't need help with that. But part 2 says, show that if z is equal to 2 cos theta, then the modulus of w, that other complex number, must be equal to 1. So this is the bit that I'm going to take a look at. So we're going to focus on part 2. And if we just start with some of the information we're given, so we have this z equals w plus 1 on w. And we're being asked to show that if z is equal to 2 cos theta, so this whole thing is 2 cos theta, then show that the modulus of w must be equal to 1. Now I think here a helpful thing to do will be to define our w in this form. Let w equal r cos theta plus I sine theta. And the reason I think to do that is because I see this 1 on w. I know I can write that as w to the negative 1, and from there I know de Moivre's theorem will help. So that's why I want it in this form. So from there now we can say z is equal to w plus w to the minus 1. So I can write that out as r cos theta plus I sine theta plus r to the negative 1 cos negative theta plus I sine negative theta. That's using de Moivre's theorem. I can expand now, so I'll go, that's r cos theta plus r I sine theta plus 1 on r cos. Now this cos negative theta can become cos theta, and this I sine negative theta will become negative I sine theta, so we'll get minus 1 on r I sine theta. So that's using even and odd function, so cos negative x equals cos x, sine negative x equals negative sine x. Now I can bring some terms together, so we'll get this equal to r plus 1 on r cos theta plus r minus 1 on r I sine theta. Now from there what we can conclude is if z is equal to 2 cos theta, then what we can do is we can kind of line up what's in front of cos and what's in front of I sine theta. So in here we've got, well, what's in front of cos is r plus 1 on r for our z. So that means r plus 1 on r must be equal to 2. And also what we can say is if we've got no I sine theta, then r minus 1 on r must be equal to 0. Now I might start with this item here because these both need to be true. So that will give us r is equal to 1 on r. Bring the r up, we'll get r squared is equal to 1. So that means r is equal to plus or minus 1. But we need to think which of these, plus or minus 1, makes this true. R is equal to plus 1. 1 plus 1 on 1 equals 2. That's fine. R equals minus 1. Minus 1 minus 1 would be negative 2. Not fine. So we actually will just take just the plus 1. So what we conclude is that the modulus of w, the modulus of this complex number, will be equal to r. And for us, we know r is equal to 1. And that's what we were asked to show, so as required. So that's how we can get to this conclusion that if this is z, then our other complex number w must have a modulus of 1. So hopefully that made sense. I think for this question the key was simply to know to define w in a form that allowed you to use de Moivre's theorem and then allowed you to get this ultimate result that could allow you to then line up the coefficients of the cos and in this case sine theta, which was 0. So hopefully you've been able to follow along with that, and tick boom.